find my favorite constellation. You're like, dude, I got this. Okay? So we know that stars kind of stick together and form these cool things that we call constellations. And we'll be talking more about that throughout the course. So what they do in science, and it's not just astronomy, but what they've done with those sets of stars is turn them into a model. Okay? So a model, let me find the word model. Okay? A scientific model is not necessarily the way it really is. It's just kind of something easy for us to look and to kind of put the pieces together. Because you guys told me the other day that stars are not all equidistant from the Earth. That's not the way it works. But they do look like they keep the same patterns. So this celestial sphere is actually kind of, and it kind of makes sense because the stars will appear to rise in the east and set in the west, just like the sun rises in the east and sets in the west. Okay, so it looks like stars are kind of rotating around the Earth. In Chapter 3, we're going to talk about the history of what we know about kind of our place in the universe. And not so surprising that early on, we really kind of thought that the Earth was, the sun orbited the Earth. Okay? Now, we don't think that's the case now. Does the sun orbit the Earth? No. The Earth orbits the sun. Yeah. So the celestial sphere has some features about it. Remember, the celestial sphere is this plastic thing that's kind of broken. Okay? So the celestial sphere has a north pole and a south celestial pole, which line up with, can you see the Earth in there? The Earth's north and south celestial pole. This seam right here is kind of in the middle. This actually is the celestial equator that lines up with Earth's equator. Okay, so we have those features that are the same. And then here's a figure of this. Now, do you guys remember we talked about the ecliptic plane? The ecliptic plane. I'll put this down here so it doesn't like. I don't know how many more drops that has. Okay, but the plane of the ecliptic is you planets were out here in the hallway. Okay, and you didn't have enough room to orbit the sun. Okay, but if you could have orbited that sun, that kind of flat region that you made out is called the plane of the ecliptic. And most planets kind of orbit the sun pretty much in a flat sheet of paper. Okay. Now, I don't know, there are certain things about this class that you just have to, you can wrap your mind around it or try to have it make sense. I'll try to show you some figures why this is. But the plane of the ecliptic is actually tilted 23.5 degrees outside of the celestial sphere's equator. And you can kind of see that right here. Here's the celestial sphere's equator, this blue one lining up with the black one. Okay. The plane of the ecliptic is actually tilted, specifically 23.5 degrees. There's one angle in this class that you're going to want to memorize, and that's the angle. See, this is 40, this is 90, okay, 45, so 23.5, like that, okay, like that. So that actually is going to be, what's this? Remember what I said this was? Axis, very good. It's a yardstick. It's the Earth's tilted axis of rotation. And what's that? Polaris. Thanks for playing along with me. Yeah, that's Polaris. So instead of being straight up and down, okay, like physics would say, basically the Earth, you're the Earth, okay, you spin on your axis, okay, and your axis is straight up and down compared to, makes a 90-degree angle with the ecliptic, it's actually tilted 23.5 degrees. So my best estimation is to make that, instead of perpendicular, the 23.5 degrees. This is so cool. They think that this tilt actually, and we'll talk more about this, that the Earth, instead of being straight up like that, it's like this, that actually was early on in the formation of our planets. It just got hit by an object about the size of Mars. Because early on in the formation of our planets, it was just a very chaotic place. Okay, so anyway, I think that's neat.
So there are planets called Is there planets?
I'm sorry, what?
Is there planets that orbit the sun like the other way?
There are planets that do that. Let's see, who was Uranus in here? You were Uranus, you're way down there. So if you could have, I know this would have been hard, but you would have like laid down on the floor and kind of twirled, spun around, okay? That would have been Uranus. Your axis of rotation is like this, okay? So, yeah. And then you kind of orbit the sun. You're a cool planet, yeah. Okay, so there's this. Oh, and did you have a question?
No, I was just wondering if that planet that hit us was named Vesta.
I think they call it Thea.
Thea.
Thea, yeah. Early on, yeah. So this is the celestial sphere again, okay? Now one of the things, and actually this model that I passed around, poor thing, okay. It also has a, let's have it upside down right now. It also has a sun in there that's not broken. Okay, I don't know if you guys can see, but I can twist this. As I twist this, it moves the sun, okay, to different places against the background stars. Now, if you're into signs of the zodiac, okay, this actually is kind of how you come about your sign of the zodiac. What background stars was the sun passing through at the time of the year that you were born? Okay. Now, how long does it take the Earth to go around the sun one time?
24 hours.
It spins on its axis 24 hours.
1
1 year, exactly. So we're going to see the sun move against the background stars to complete one circle in 1 year's time. So I'm going to pass this around one more time and take a look at where the sun is, and you can kind of see these are different days of the year. Okay. Now this is, again, is a model. Does the sun orbit the Earth? No. But it kind of, this is literally what we see, so it kind of actually goes a little ways. So I should just order a new one of those. Actually, I will. I've got, they've got some money out there, so I'll see what I can do. Oh, that reminds me, the other day my Amazon order came in, and that little gizmo where if you have a smartphone, you can take a picture through an eyepiece, like a telescope eyepiece. I put it, it works on binoculars too, so I didn't set up my telescope, but I put it on binoculars, and so I took a picture of a squirrel nest in our backyard. So it is so fun. I'm like, oh my gosh, I think it's going to work. Okay.
You said it takes 1 year for the Earth to orbit the sun?
It takes 1 year for the Earth to orbit the sun, yes. Yep. And they had a whole calendar issue. It's kind of interesting, like in the 1600s they kind of straightened it out, but it's a little more than, a year is a little more than 365 days. It's 365 and a quarter days. So some of you are familiar with the whole leap year thing. Every 4 years we pick up a 29th day in February. Mm-hmm. Mm-hmm. Yep.
But
So.
in the book it said that it takes the Earth 23 hours and 56 minutes.
Right.
So that doesn't make any sense. Like,
I think I have a slide on this. That's the sidereal day and the solar day. That's the rotation thing. What she's talking about actually is an issue too. If I'm going to go ahead and make this the sun, okay, and I'm going to be the Earth, okay. The problem with the Earth, not that you're too much of a problem, but you are kind of a problem, is he's got two things going on. She's got two things going on. She's completing one orbit in 1 year, okay, and she's spinning on her axis, okay. So you would tell me this is daytime and my back is nighttime right now, okay. I do this in 24 hours, okay. But the thing is, I also advance in my orbit a little bit. So it kind of, there's something called completing one orbit, one rotation, not an orbit, one rotation. That's called the sidereal rotation. And then there's when is daytime really come next, and they're slightly different because of that. So stepping out, no one out there was the Milky Way this time. One other time we'll have to kind of pull out my sheet that says Milky Way. So how does the sun fit in the Milky Way? How does that work? You guys remember? Yeah, it's about halfway. The sun is just a star in this frisbee of stars we call the Milky Way galaxy. Now, has anybody ever seen a picture of the Milky Way galaxy, the whole? No. Okay, but that's kind of what it looks like. The best thing that we can do is actually, and I think as that comes around, can you kind of see the ribbon, the kind of the long lines? That's the Milky Way. So I never thought about it much, but if we look at the celestial sphere, it actually has kind of a ribbon, like I said, that's representing the plane of our Milky Way galaxy. So that's kind of cool. Those sky maps I gave you for this month, how are we doing with our labs? It's been very cloudy, I know.
I'll wait until it warms up just a little bit.
You're gonna wait for it to warm up. That all sounds right. Now, if this semester is terribly cloudy, we'll have to go to Plan B. So just keep working with me. We'll get, how many labs do you guys need to do?
4, I think.
We'll make it happen. Okay, but this sky map, so the Milky Way is this right here. So you can actually see that that is the plane of our galaxy. All right. So I think I have next, I have a few photos again. I'll go ahead and dim all the lights. Now these were not taken through my telescope. These were just taken with my camera on a tripod. Okay, again, I have to kind of take long pictures because the light, I have to catch extra light from those stars in order for them to show up in my digital camera. I've also, for my tripod, got a fancy thing that keeps up with the rotation of the Earth. Okay, if I didn't, actually I would see star trails. So I've got kind of a little tripod thingy. I know. My husband's so supportive of my hobby.
So like, if you don't hold your camera still enough, it'll start.
Right. The thing about not having a tripod is if you open your shutter for even 10 seconds, without a tripod you'll be kind of shaky and it'll kind of make them like that. But even with a tripod, if you open up the camera for, I don't know, 20, 30 seconds, you're going to see those stars move a little bit. So I have to kind of keep up with that rotation. So anyway, if you get a chance, this is one of the 2 domes at the Whitty Observatory. So that's kind of cool. You guys see the slit right here? This slit right here, it's open at the other side. I think I mentioned it kind of looks like a silo. Okay, so the top part rotates. I love that rotation, okay? Now, I can't operate this telescope. This telescope, it's on my list of things to do. I used to say bucket list, but it's on my list of things. This telescope has got a 16-inch lens, or excuse me, 16-inch mirror. So it's pretty big, kind of heavy. So anyway, you guys see the Milky Way? Yeah. Here's the Milky Way taken at my in-laws' homestead down there in Mississippi. So just pictures of the Milky Way. This right here, can't help but miss it. This thing right here, okay, that's actually just a jet going through, okay? So you can kind of see it was open long enough to have the jet kind of make the little light go through like that. There.
So do you just stop what you're doing and go outside and you're like, I gotta take some pictures?
Yeah, it takes a while to set up and there has to be planning, but I'm always looking at the weather, it seems like. You know, it's like, oh, is it going to be clear? Can I? Or is it too cold? I'm not going to go out. So here's some important terms on here. So here you have the gal in the middle, and she's kind of pointing to the sky where she might see some stars. So there's some important aspects. Right above your head, wherever you are, because so it's going to change with you, is called your zenith. Okay, so right straight above you at a 90-degree angle with the horizon, that is your zenith. Now, there's this thing called altitude, and altitude always goes from the horizon. So I know I can't like go down here and make my horizon, but just pretend like this is my horizon. Okay, I'm on the floor, this is my horizon. So my altitude is this angle right here. This, if something's on your horizon, that's 0 altitude. Okay, this figure says your zenith is, what degree is that? 90. That's what your zenith is, 90. Okay, so kind of in between, that's your altitude. Now, we know that things like stars appear to move throughout the course of a night. They rise in the east and they set in the west. Okay. Also, what's the clock for this semester? Polaris. Do you remember what direction, clockwise or counterclockwise, did I say stars appear to go around Polaris? Counterclockwise. Very good. So I'm kind of, make sure I stay honest. So they'll go like this, counterclockwise. Stars will go like that. Okay. My point was going to be that as a star kind of moves like that, its actually angle with the horizon is going to change. So if people who are into finding things in their sky talk about their altitude. The other thing we need to talk about is where is it relative to this direction. So altitude is kind of like latitude on Earth, okay? And where is it along kind of a circle? Okay, that's what we call longitude on Earth, kind of. That's what I think, lines of longitude. So basically what you do is you find north and you make that 0. So let's see, north, okay, we make that 0, okay. Here I'm going to turn all the way south. How many degrees have I gone? 180, very good, very good. And then if I go ahead, let's go instead of south, we're going to go, this is west. I've gone another 90. What's 180 plus 90? 270, very good. So this would be 270, due west. Okay, then I come around here, 360 or 0 again, basically. Okay, so that is actually called your azimuth. Okay, so we have altitude, okay, with your horizon, and then we have azimuth. So that kind of pinpoints things. So I thought I was playing around. I don't know if you guys have had a chance to look at that Stellarium program yet, but I'm going to pull that up right quick, I think. I have to do some. And I just want to kind of show you what that looks like. Here. Stellarium. Okay, so remember, if this is hot, if you first download it, you're going to have to tell it where you are. But it pretty much knows where we are. And I'm going to go ahead and forward. I'm going to pull up the date, the time, and I'm going to go to later tonight. It's military time, so that's 1, 2, 3, 4, 5, 6. That's pretty good. Let me kind of dim some lights here. So 7:30 tonight. It was going to be clear, but now I think it's going to be cloudy. Oh, drop that. Okay. So remember, we could add the constellations. The way this program works is you kind of zoom down here at the bottom, and these things come up. Your menus, you have a bottom menu and you have a side menu. And along the bottom menu is a way to go ahead and add constellations. You can add 3 types of constellations. I'm not going to add in the pretty pictures. I just want the lines and the names. So my point was going to be, if I want to, for instance, and some stars have awesome names, like what is this constellation right here?
Orion.
It is Orion, very good. And these are the belt stars that I was talking about. We're going to pick on Orion a little bit this semester. Because here in Orion's, do you know what they call this part of the Orion? If this is the belt, what's hanging from the belt? There's letter S.
The sword.
Sword, very good. This is the sword of Orion. And even with binoculars, you can kind of see this greenish sort of fog out there so far away in outer space. And that fog actually is what we call a nebula, where stars are being born. That is so cool. Okay, so there's Orion, the belt, the nebula. So let's just say we wanted to, let's pick on the star called Betelgeuse, great movie, okay? And I'm just pulling this up here so we can look at, for Betelgeuse right now, in the person's, in our local sky at Burlington, do you see where it has AZ stands for azimuth, okay? The azimuth is 123 degrees. So you're like, okay, well, this was north, that's 0. South is 180, okay? So here we got 90, so 120 must be here-ish. You see how that works? Now, do you see where it's changing its location? Why is it changing its location? Yes, it's rotating away from us because the Earth is rotating on its axis, exactly, okay? Let's see what the alt part is. Now that is your altitude. Alt is altitude. And so is that changing too? Yeah, a little bit. So 42 degrees, okay, so your zenith is, so we're over there, right? Kind of ish, okay. Your zenith is 90, this is 0, so we got about 45, 42. So this is just to kind of say in there-ish is where you would find Betelgeuse. So that's just kind of how it works. Now we're going to talk more about, in case you're not real familiar, of course, the circle means degrees. What does the 1 hash mark mean? Do you know? What comes after, what do we have 60 in an hour?
Hours?
Minutes. Yeah, minutes. The 1 is a minute. What's the double line? Seconds. Yeah, exactly. So we're going to kind of have a slide on that in a minute. So let's see if I can, now to get out of here, I go down to the bottom menu. I can either close it out entirely, or this is to shrink it down. Go ahead and just try shrinking it down for now. See if we can go back to this.
So you always use the azimuth? You can't just say like southeast or?
No, yeah, no, she's right. You can, in fact, when I'm out at the observatory, some just people say southeast, north, west. You know, they don't use the degrees. Definitely, you don't have to always do that. I need to kind of fix this. Okay, very good. Okay, so the other thing, here, I'll take that one, sorry. I noticed I've got a little bit of plastic up here. Somebody said super glue. That is exactly what I need, super glue. You just rest a little bit and we will, it'll be fun. We'll buy a new one of those. The other thing is how big is stuff, okay? And so you guys told me, let's see. You guys told me, well, let's do it this way. This is 90 degrees, okay? Now I should be able to kind of talk about the kind of different degrees between 0 and 90. And it kind of works out pretty good with just an adult's hand. Everybody's a little bit different, but everybody hold out your hand and point it to that board, okay? Now, if there were stars out there or something, okay, well, just say against the celestial sphere, hold out your index finger. That is 1 degree on the sky. That is 1 degree on the sky, okay? Go ahead and extend your whole palm like this. Just like Simon says. Okay, that is 20 degrees. Okay? Go ahead and make a fist. And that is 10 degrees. And honestly, on a given night at the observatory, I'll have friends that be like, well, how far is that object from Betelgeuse? They'll be, oh, like 10 degrees. Or it'll be 12 degrees. And so they'll hold up their fist. They're like, well, that's 10. So another 2 would be, I guess we could hold up our fingers, or like that. And so literally we do a lot of star hopping, a lot of like, oh, that's in the vicinity, how close is it? Well, let's kind of let's use what we know to find it.
What is the measurement on A, because it's like cut off on our PowerPoint?
Oh, maybe it's coming back. Does that help?
Because we have that part, but we don't have A.
You don't have
It covers
A?
over A.
Oh, I think I know what you mean. Okay. So you need the words for A?
Yeah.
Okay. We can do that. Oh, sorry. There, is that better? Okay.
And then I think I have it all, but after about like one half. Okay.
About 1/2. Very good. Thanks for, well, thank you. Thanks for pointing that out. So an example of using it to our benefit looks like this. Oh, goodness. Oops, go back. And then change. Oh, that's not what I wanted. I like this topic. So how many, and I'll include myself in this, I'll just say I feel like the moon is bigger when it first comes up. Are we? Yeah, we're totally on the same page. So this slide tells you the moon, go ahead and hold out your finger again, okay? The moon would be about 1/2 of a degree. So it should be about the half, and everybody's finger is a little bit different, but about 1/2 of your finger. Okay, that's the moon. So, hey, you can put your fingers down. Thank you. You did good. So next time the moon comes up, or you see the moon rising, okay, rising in the east, or it looks really big when it's setting too. Okay, hold out your finger and see if it's about a half of your finger wise. Okay. What's that?
I think mine's gonna be my whole finger.
Okay, you have kind of petite fingers. Yes. So, does the moon, should it change size as it orbits the Earth? No, and it's kind of similar distance from the Earth. So honestly, once you do that, I guess the other part of that story is when it's high in the sky, go ahead and do the same thing and see if it is the same size. And it really should be, about a half degree. So the solar disk, by the way, is about a half of a degree too. Okay, what else we got? So this was that whole degree is the 360 degrees in a circle. You guys maybe would tell me that. Okay, 360 degrees in a circle. And there are 60 minutes in an hour. So kind of along those lines, we go 60 minutes in 1 degree. And there are 60 seconds in 1 minute. And that's an angular minute. So that's kind of how that works. Let's see. Switching gears, okay, from our local sky to something maybe you learned in elementary school. I don't know. Okay, so here's the Earth. Who was the Earth, little biggo? You were the Earth. Did we have an Earth out there too?
Yeah, I was.
You were the Earth. Thank you. Okay, good. All right, Earths. Okay, so what is this line right here?
Equator.
Equator. Very good. Equator. And not just the Earths have to answer it. Anybody can answer it. What degree latitude is this?
0.
It is 0. Perfect. So this is 0 degrees latitude. Awesome. Latitudes, by the way, are kind of go in big circles, great circles. So there's the equator latitude, okay, and then there's the 23.5 degrees latitude. That's actually what we call the tropics of Cancer and Capricorn. So 0, 23.5. Then we have 66.5 degrees, and those are our Arctic circles, okay, Arctic circle and Arctic circle. And then what's this latitude up here? What's the pole latitude? If this is 0, what's this? 90, very good, yep. And actually, you can kind of think of the whole going like this. So this is 23.5, this is 66.5, this was 90. Okay, so those are kind of like what we call great circles. Anybody know what latitude we're on about? Does it say on there?
Looks like -30 on the picture.
It does look like it could be -30, but actually this is an approximate sign. Yeah, this means this is approximate. I know, it looks like a negative, but it's like
I also don't have on my glasses.
yeah. So we're a little bit north of 30, very good though. We're about 42, 43 degrees latitude, okay? The great circle. All right, longitude, lines of longitude. They actually then go, I always think long longitude, so they go long like this. Now they don't go all one circle, they just go kind of from pole to pole. That's a longitude line. And you figure we had to start somewhere, so the place it starts actually is in Greenwich, which is the 0 longitude, dun dun dun. Our friends across the pond, right? Okay, are right, this is, I see England, so the prime meridian is, I'm looking at a 0 right there, okay? 0 longitude, okay? So we are, so you guys told me what direction does the Earth rotate? Clockwise or counterclockwise? Counter, exactly. So let me go ahead and put a little bit of spin on that. I'm going to go counterclockwise. If you guys are basically the sun, okay, where my finger is, this is noon, okay? I'm going to kind of make the Earth rotate. Now this is noon, now this is noon, now this is noon. You guys know that we have this whole time zone thing going on, right? Okay, good. About every 15 degrees longitude, we get a new time zone, basically. Okay, time zone, time zone. So here we are in the United States. Okay, who gets to see the sun first? East Coast, yep. So we have Eastern time zone, Central time zone, Mountain time zone, Pacific time zone, exactly. What was I gonna say? Oh, yeah. Okay, so this is so cool. Okay, I'm gonna go back, this is us. I'm gonna go back to the prime meridians. This is 0. Okay, so you figure we keep going here, this is 0. What happens when we get opposite of 0? So that was 0. I don't know if you guys can see this dot, 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 dot. But basically, we have, is this east? This is west, right? We have west of the prime meridian, that's where we are. And then we have east of the prime meridian. Okay, lines of longitude. Okay, where they meet up back over here, okay, is actually called the international date line. That is so awesome. Oh my gosh, it hurts my brain. So if you're over here, you're one day. If you're over here, you're a different day. Okay, that's the international date line. Can you imagine doing any business there? I just think that would be crazy. So that's kind of how that works.
Might have its advantages.
It might have its advantages, right? Oh. Okay. Where are we at? I think we're going to hold off the next few slides. This is a good place to kind of get a clean break, and we'll take a run and start at this on Friday. But that does mean that Chapter 2, we didn't get all through it, but Chapter 2 assignment is due on Friday. So any questions about, we've got a few minutes. Let me just tell you, in case you don't remember, you guys can submit your assignments this semester in a couple different ways. If you're one that likes to just to write the darn thing out and hand it in when you come, okay, just do that. Okay, if you're one that says, oh, I forgot to do it, and you go rush out of here and do it, then hand it in by 3 o'clock on Friday. Okay? Your other options go like this. If you're a techie, okay, and you like to use the course website, and I've actually gotten 3 people that have just gone ahead and given it through the course website. You get till midnight to do that.
Midnight on Friday?
Midnight on Friday, yes ma'am.
Oh.
So you might want to become a techie. It's not too bad. It's not too hard. Any questions? All right. We'll see you on Friday. Friday.